Hi guys, Mrs. Dan's here. So today we'll be reviewing our exponents, scientific notation, and roots. Remember, we have the signs posted on my wall over by the windows, but I am going to do a few problems with you just to remind you of some stuff. Today in Google Classroom, there are the answers to your homework that you did about linear equations and functions. So make sure you check that. And next time I see you, I can answer any questions that you had if you got some questions wrong. Because remember, you do need to know how to graph linear equations for your final exam. So let's get on with today's packet. Like I said, there were a few problems I wanted to do with you. So there are some rules here that you can look over, but again, I have things hanging on my wall. I think the best way to review this topic is by doing practice problems. So on this page, we will do the whole first column. Question number 1 is about multiplying with exponents. Remember, the rule is to keep the base and add the exponents. So this should turn out to be x to the 5th power. I just want to also remind you that if you forget the rule, because there are so many rules, you could always expand this and you're guaranteed to get the right answer. Remember that x to the 2nd means x times x. And x to the 3rd means x times x times x. And then take a look. You can see that there are 5 x's being multiplied. So that's how come the answer is x to the 5th power. The rule on number 5 for division with exponents is to keep the base and subtract the exponents. So I know this answer is x to the 2nd. But once again, if you forget the rule, expand it. The numerator says x to the 5th, which really is x times x times x times x times x. And remember, this has a fraction bar, so underneath it is where I do x to the 3rd, so that's x times x times x. And when you have a fraction, we can simplify. Remember, a number divided by itself is 1. So if I divide x by x, right here, I get 1. This x divided by x is also a 1. And this last x divided by x is also a 1. So in the numerator, I have 1 times 1 times 1 times x, which means my numerator is x squared. In my denominator, I have 1 times 1 times 1, which is just a 1. Remember, you don't need a denominator of 1, so that's how come the answer really is just x to the 2nd power. The rule for number 9, this is, I've always called it a power to a power. The rule is to keep the base and multiply the exponents. But you can see that now we're starting to talk about so many rules and we can easily confuse the rules. So instead of memorizing rules, why don't we just follow what the basics of exponents are? So here's some parentheses with an exponent of 3, which means the parentheses get written 3 times. Inside those parentheses, it says x to the 2nd. But now I can expand each of those parentheses. So I'm just looking for another color, sorry. So x to the 2nd is x times x. X to the 2nd is x times x. X to the 2nd is x times x. How many x's did I write out? Yeah, there's 6 of them being multiplied. Of course, the answer is x to the 6th power. On number 13, I only do this one by expanding. So in parentheses, I have an xy. Those parentheses get written out 3 times because of that exponent. So xy is getting written out 3 times. I can do this next step in my head. I know that the answer is going to be x to the 3rd, y to the 3rd, but I can also use the commutative property and say that there are these 3 x's that I want to write out, and then there's the 3 y's that I can write out, these 3 y's. So clearly it's x to the 3rd times y to the 3rd. On number 17, when you have a fraction in parentheses to the 3rd power, it really means that that fraction is being written out 3 times. So I have xy times x over y, I'm sorry, times x over y times x over y. Now look at it separately. In the numerator, I have x times x times x, that's x to the third. And in the denominator, I have y times y times y, that's y to the third. That's the final answer. X to the third over y to the third. Now, remember, negative exponents are not negative numbers. Negative exponents are fractions. So this is just something you need to remember. You can look at one of my signs on the wall right now if you need to. But anything to a negative power means you write it as 1 over that thing to the positive power. So it's 1 over n to the second. That's the answer. It's just 1 over n to the second. I'm actually going to do 22 right now. This would be 1 over 4 to the second. Since this is a number to the second power, I can actually evaluate it. 4 to the second is 16. So the answer is 1 over 16. Notice it's not a negative answer. It's a fraction answer. 4 to the negative second is equal to 1 over 16. That's the answer. I'm going on to number 25. Anything to the 0 power is always 1. That's something you should just remember. And when I do number 29, I actually like to expand it and simplify. Whenever the exponent in the denominator is larger than the exponent in the numerator, I know I'm going to have a fraction answer. I know if I were to follow the rule, I would get a negative exponent. I will do this following the rule also, just in case you want to see it. But right now, with the expansion, this is a 1 and this is a 1. In the numerator, I have 1 times 1, so I have a 1. In the denominator, I have 1 times x, which is x. This is my answer, 1 over x. Right? A numerator of 1, of course, needs to stay there. If I were to follow the rule on this one, the rule is keep the base, subtract the exponents, but 2 minus 3 is negative 1. Negative exponents are not considered simplified. I'm not allowed to leave my answer as x to the negative 1. So I rewrite it as a fraction as 1 over x to the first power. First powers don't need to be written, so that's how come the answer is 1 over x. All right, so I'm moving on to the next page. You will finish this page on your own as part of your classwork and homework. And again, there's some rules up here, but I'd like to just do some problems with you. So number 53A. Remember, this symbol here is a square root symbol. Square root means think of a number times itself. That gives me 81. What number squared is 81? It would be 9. This answer is 9. I don't say it's 9 squared. I say it's 9. I can prove that the answer is 9 by saying that 9 times 9 is 81. But remember, I'm looking for the one number that if I squared it, gives me the 81. So the final answer is 9. If I were to do D, what number times itself is 144? It's 12. Okay, but sometimes it's hard to do square roots without a calculator. Like there isn't a whole number times itself that gives me 32. So this is in between two whole numbers. Maybe you can think in your head what two numbers it's in between. I know it's in between 5 and 6 because I know 5 times 5 is 25. So the square root of 25 is 5. And 6 times 6 is 36, which means I'm thinking of the square root of 36. The square root of 32 is in between the square root of 25 and the square root of 36. So the square root of 32 is somewhere between 5 and 6. It does say round to the nearest thousandth, so let's open up that calculator of ours. And on my calculator, I want to do the square root of 32. And if I rounded it to the nearest thousandth, that's like the third decimal place, remember that we need to look at the number after it. So since this is an 8, this 6 rounds up to a 7. So rounded to the nearest thousandth would be 5.657. 5.657. So be careful with your rounding on your regions, on your final exam. A question like this would be a multiple choice question. And of course, like an incorrectly rounded answer would be one of the choices. So please be very careful. This is cube root, right? See this little 3 here? It's got the square root sign, but with the little 3. So it's actually cube root. It means think of a number that if I multiplied it by itself 3 times would be a 64. So that would be a 4. Again, you can do this on your calculator. So your cube root button on your calculator, since I'm not in the classroom looking at your calculator right now, I'm having a hard time remembering where it is, but it does say, like, I'm going to write it down. It's like an X with a Y here. And you need to type in the 3 and then use this button to put like your number 64 here. If I were to do it on my calculator, your mine's a little different than yours. Mine's in a different button than yours. Right here, my number 5 has like the X outside and it has this symbol. So I'm going to type in 3 and then I'll use my number 5 button and then type in the 64. And it does tell me my answer is 4. Help each other find the button for cube root. And when you see me, if for some reason you're having a hard time finding it, I could show you where it is. Number 56, they're asking to go back and tell me for numbers 53 to 55 if it's rational or irrational. Remember, a rational number is like a number that can be written as a fraction. If it can be written as a fraction, it means its decimal form would be terminating or repeating. But these irrational numbers, those are the numbers that are like crazy and they fill up your screen with digits. We say that they're non-repeating, non-terminating decimals. So if I were to go back to the few that I did, this is rational. It's a nice normal number. This is rational. Whenever you take the square root of a perfect square, the answer is rational. But on number 54, when you take the square root of a non-perfect number, remember we had a roundness answer because the decimal filled up our screen. This is an irrational answer. And again, cube roots that are nice, these are rational. If it was like a crazy cube root, if the decimal filled up our screen, then it would be irrational. Number 56 is super important to pay attention to. Definitely a multiple choice question. Okay, when it's written like this, they're asking what number to the second power of 16. So many people just want to say that x is 4 because 4 times 4 is 16. But remember, x could also be negative 4 because negative 4 times negative 4 is positive 16 also. So there are 2 answers. There'll be a multiple choice question on your final exam. Choice 1 will say like x equals 4. Choice 2 would say x equals negative 4. Choice 3 would say x equals 4 and negative 4. And then choice 4, I don't know what it would say. But there are 2 answers when it's written in equation form like this. So now I'm going to skip ahead. I'm not going to do any questions from this page. I just went over all of that stuff. But go on to this next page, number 11. I want to review your scientific notation. So remember, scientific notation, I want one digit and then a decimal, and then whatever digits are left over go after it, and you multiply it by 10 to some power. This power can be positive or that power can be negative. When it's a small decimal number like this one, the exponent's going to be negative. When it's a large number like this one, the exponent will be positive. So if I were to write number 11 in correct scientific notation, I want the 4 on this line. Whatever left over goes after it, so there's only an 8 left over. Since it's a very small number, I count how many decimal places. 1, 2, 3, 4. So it's a negative 4 exponent. It's choice 3. If I were to write number 12 in correct scientific notation, I want one digit, a number, and whatever leftovers there are. Those leftovers are not the zeros, though. It's the non-zero numbers. So I'm going to write 5.4 because this power of 10 is what takes care of these extra zeros. 1, 2, 3, 4, 5, 6, 7. Remember, you always count to where you want the decimal to be. So it's not choice A because that says -7. It's not choice B because that says 54 instead of 5.4. So it's not choice C, it's choice D. 5.4 times 10 to the 7th power. And I think, yep, there's one more I want to do. We'll do number 15 and then I'm done and you can work on your problem. Product, remember, means to multiply. So what is the product of these two numbers that are in scientific notation? If you remember, we multiply these normal numbers first. 6 times 3 is 18. And then we multiply our powers of 10. 10 to the third times 10 to the second. The rule says keep the base, add the exponent, so it would be 10 to the fifth. But don't choose choice D. I see 18 times 10 to the fifth, but I wish this had another part to our problem. On our final exam, it should say choose the choice written in correct scientific notation. And unfortunately, that choice is not here, right? 18 times 10 to the fifth is there, not correct scientific notation. Remember that we need to fix this and write it as 1.8. But if we're going to fix that and write it as 1.8, it means that this exponent has to change. In this original number, I was moving the decimal 5 places to the right. So starting from here, going 1, 2, 3, 4, 5, makes me write this number. Well, if I need this to also be that same number, but I'm going to start counting from here instead. Now I'm counting 1, 2, 3, 4, 5, 6 places. The answer, the choice that I wish was here, was 1.8 times 10 to the 6th. If that choice isn't there on your final, which it should be, then I guess the only thing you can pick is choice D, because the directions here really doesn't say correct scientific notation. But if it says correct scientific notation, you have to choose this choice. And I'm done. You're going to finish this packet and we'll go over it tomorrow. Okay, see ya. Bye.